Well, welcome to section 1.5, Solving Inequalities. And one thing I want to start off with is saying that solving inequalities is very similar to how we solve regular equations. So let's keep that in mind as we're looking through this whole section. As I've told you before, some of these problems that they have in the book are very dated, and the book is only about 8 years old. You can see there's a problem here about how much information or how many songs to download on your MP3 player. I'm not even sure they make those anymore. I think it's all iPod world. And they talk about having 19.5 gigabytes left. And I think most of the things that we use for recording is probably, I don't know, probably about 50, 60 gigabytes or 100. This just seems like a very out-of-date thing. So it's more funny than helpful, I think. Anyways, let's move past this initial example and talk about some of the key concepts of writing inequalities. And if you look here, these would be great notes, again, for your Cornell notes, talking about greater than or equal to, less than or equal to, where you have greater than or less than, the open dots, and where it's less than or equal to, it's greater than or equal to or less than or equal to, that's where you're going to have the closed dots and shade accordingly. So let's take a look at writing our first inequality. We've got x minus 5 is greater than or equal to 12. This is how it's going to look in English, and here is how it's going to look in Mathanese. I don't think there's such a language as Mathanese, but there should be. And the quotient of a number in 3 is no more than 15. You can see the example right here. The kicker for the first one is that a 5 fewer than a number is at least. That means it's got to be greater than or equal to. At least it's 12. In other words, that's the lowest, and this is going to be greater than the 12. Here, no more than 15 means that that's the actual limit. No more than 15, all of these and all this here has to be less than or equal to 15. So let's talk about graphing these. What is the solution to this, and then graph it? Well, just like I said earlier, solving inequalities is very similar to equations, solving equations. So first I'm going to have to distribute here. Negative times a negative is positive. Is greater than or equal to 4. Combine like terms, 15 and 1. Get all the numbers on one side, all the variables on the other. So here I'm going to subtract 16 from both sides. And I'm going to have negative 6x is greater than or equal to 4 minus 16, negative 12. And this presents us with one of the few things that is different about inequalities as opposed to equations, is that we have to divide here by a negative number. And anytime you divide by a negative number, you will have to switch the inequality. So we divide by negative 6. These are going to simplify to 1. Flip the inequality, and then divide or simplify this. This is going to be positive 2. Negative divided by a negative is going to be positive. 12 and 6, or 6 goes in 12 2 times. So now let's go to graphing this. X has to be less than or equal to 2. So go right to 2 and ask yourself, is it going to be closed or open? Well, this situation is going to be closed because of the equal sign underneath. Then ask yourself, x needs to be all the numbers less than or equal to 2, which is going to be this way. So I'm going to shade to the left here, if I can find my appropriate shading. And I'm going to go ahead and shade this green. It's going to be this way. Just like the picture they have right here. So let's go ahead and try this other one here. That's my cat in the background, if you haven't already heard. Poor Elsa. Anyways, she's going to live, maybe. Let's take a look at, first of all, distributing here, and then adding 5 to it. Elsa loves math just as much as the next kitten. She did all her homework, so she's very happy. So let's go ahead and distribute here and then simplify. I need to go ahead and get 18 on both sides, so I'm going to do the opposite operation. And then I'm going to be left with 2x, negative 2x, thank you, is greater than or equal to 3 plus 18 is 21. So that's going to leave me with, oh, I forgot my little 5 up here. Oops, well, happy little mistake, I think. Let's go back and erase this. Forgot that plus 5. I must have a vision problem of some sort. I think I do. Let's try this again. There we go. Then combine like terms. Negative 18 and 5 is going to be negative 13. And we're going to go ahead and add that 13 to both sides. And we're going to be left with negative 2x is greater than or equal to 16. Divide both sides by negative 2. And if you recall, there's a little something we have to remember. That means flip the inequality when we're dividing by a negative, or multiplying both sides by a negative. X is now going to be less than or equal to negative 8. So let's go to negative 8, make a closed circle because it is equal, less than or equal to, and we'll go ahead and shade this. Less than means it's going to be to the left. Let's go ahead and look at our first story problem. Let's talk about movie rentals. I'm not sure, again, how dated this is, but we rarely rent movies. It's all about Netflix nowadays. A movie rental company offers 2 subscriptions. You can pay $36 a month and rent as many movies as desired, or you can pay $15 a month and $1.50 each to rent the movies. How many movies must you rent in a month for the rest of the plan to cost less than the second plan? Well, let's take a look. First plan, $36. The second plan is $15 plus 1.5 times the number of rentals. So we want this to see, or we want to find out how many movies must you rent in a month for the first plan to cost less than the second plan. Well, let's write out what we know. We know we have 36 on this side and 15 plus 1.5n on the other side, or $1.50, I should say, on the other side. Now, which side needs to be greater than? Well, let's go back and take a look. How many movies must you rent in a month for the first plan, that would be this one, to cost less than the second one? So 36 has to be less than the second one. Not the same as, so it's just going to be a less than symbol. Now let's go ahead and simplify. Subtract 15 from both sides. And then divide 21 by 1.5. And there we go. We're going to have the movies be greater than 14 movies to be less than. Let's go ahead and take now a little bit of time to take a look at what kind of solutions might we encounter when we're working on inequalities. Well, let's simplify this one and see what we get. Distribute all the way through. Add 6x to both sides. And we're going to have negative 2 is greater than 7. Is this true or false? This is a lie for sure. And that means we're going to have no solution. Because negative 2 is never greater than 7. Let's try the next one. Distribute. Combine like terms. And then subtract 3x from both sides. Is negative 15 less than or equal to 8? True. And that means you're going to have all real solutions. In other words, any real number you plug in, you will create a true inequality. So let's go ahead and finally take a look at and or statements. I believe you should be able to recall these from your year as an Algebra 1 student. So let's take a look at refreshing our brain cells. This is an and solution. Right here it says the word and. In other words, we need to find a number that will satisfy this inequality and at the same time satisfy this quality. And we're going to do that by graphing our solution. So let's take a peek. Let's simplify this one right here. Subtract 1 from both sides. And divide by 2. Don't forget your and statement. And you're going to have to divide both sides by 3 here. And you're going to have x is less than or equal to 6. So we've got this. 3 has got to be less than x. So I'm going to go to 3. I'm going to put an open circle here. And x has to be greater than 3. So I'm going to shade to the right. My shading is a little off today. We'll work on that. The next one is x is less than 6. So I'm going to pick another color here. I'm going to go to go to the 6. And I'm going to fill in that circle because it is less than or equal to. And now I'm going to go ahead and pick another color here. I think I picked blue. And then I'm going to go all the way down here, and hopefully, yes, it does actually shade correctly. So we've got ourselves a little bit of a mess right here with these two different shades. Let's take a look at the more important part, as the and. I want to have the same here and here be true for the whole statement. So all the numbers 3, 4, 5, and 6, this is your and statement. And to quickly wrap this up, and means overlap. Your or statement is solved just like this. You go ahead and solve for k, and then put your dots, and then your shadings.